Hi students, we'll solve problem from projectile motion. For better understanding of this problem, you can refer video lectures of projectile motion theory part 1 and part 2 so that you'll understand this problem clearly. Now what is given in problem, just see here. A ball thrown by a boy on the street is caught by another boy in balcony 4 meter above ground and 18 meter away after 2 seconds. Calculate initial velocity and angle of projection. That means u0 and theta 0 to find out. Always we'll try to draw a simple figure for problem so that solving problem becomes easy. Now here say this one is a ground. Okay, this is nothing but ground. And there is a building, you can say, because another boy is in balcony. So that means we'll represent one building, you can say. Say this one is nothing but a building, which is on the right side. Okay. And one boy is standing here. One boy is standing in a balcony. So I'll represent small terrace here because this one is some open terrace and one boy is standing here. Okay. Now, so one boy is where? In the balcony. Another boy is where? So that boy is on ground. Okay, this one is a position. Say from where this ball is thrown from ground, this point is A. Okay, and this ball is thrown with some velocity, right? From where? From ground. Therefore, what we'll do here, I'll represent here that initial velocity of projection. Okay, that is from this one, ball is thrown, you can say like this. That means this velocity, what will represent here is called as what? This is initial velocity of projection, and this inclination of velocity will be represented by theta 0 called as angle of projection. Now ball is thrown from this location and this path traced by this particle, if we represent, means path traced by this ball. So it is always parabolic in nature. So this ball moves from this position and it is caught by a boy here, right? So this one is a location of, you can say, a boy. There is one boy who is standing here, right, like this, and this boy just take catch of this, and here on the ground there is one boy. Now some distances are given. What distances are given will represent the horizontal distance of this boy from, you can say, building, that means from balcony, will represent this distance, you can say, as horizontal distance, and height of this location from ground is this distance. Okay, this is from ground. Now what dimensions are given? These are, this one is a height, right? This one is height. Now what is given? What is the height? 4 meter above ground. That means this distance is 4 meter from where it is thrown and where it is caught. Here the horizontal distance is here. This is given as 18 meter. Okay, say we'll give some name to this point as, say, B. That means motion of this ball is from ground, means point A up to point B, from A to B. Now first step is what data is known for this motion from A to B. Now from A, B is at what horizontal distance? 18 meter. That means what is given? So it is x distance. X is how much? 18 meter. And final position means B is above initial position A. When your final position is above initial position, then y is positive. Here what y is given is what? This is plus 4 meter. When this y becomes negative, if final position is below initial position, that means the case maybe, you can say, from the top of a hill, one body is projected and strikes on the ground. That means at lower level, then y becomes what? Negative. In this case, y is positive. And it reaches here after what time? It takes some 2 seconds. That means this is total time of flight. X is known, Y is known, and T is known. What you have to find out? Initial velocity of projection means u0, and inclination means angle of projection, right? Angle of projection also you have to find out. So this one is unknown. Okay. Now applying our equations of motion, there is one equation in horizontal direction and three equations are in vertical direction. Therefore, now if we'll apply equation along x-axis, so along x-axis there is only one equation, x equal to u0x into t. u0x means horizontal component of velocity. Now what is known here? X is known, which is what, 18. u0x unknown, okay, and time t is what? So this is 2 seconds. That means what is possible is horizontal component of velocity, initial component of velocity, which is horizontal. 18 by 2, that means this is simple to calculate. This is 9 meter per second. Now we have to try for vertical component of velocity. To find out vertical component of velocity, as you know y, if you apply equation of y, so y is, equation is like this, u0yt minus half gt square. Y is 4 meter, u0y, this term is unknown, u0y will write as it is, okay. Time t is 2 seconds minus half g is 9.81 into 2 square. Using calculator, simply find out this u0y. If you calculate, this value comes out to be 11.81 meter per second. Now if you know two components of velocity, easily resultant velocity and inclination is possible. I will represent here components of velocity. Your vertical component of velocity means say u0y, right, vertically upward. Horizontal component of velocity rightward, this is u0x, and resultant velocity is in same quadrant here. So this one is u0, okay, this is u0, and inclination is what? Theta 0. Now applying Pythagoras theorem, we will find out u0. To find out u0, that is equal to square root of u0x square plus u0y square. So if you substitute u0x and u0y, you will get u0, and this one comes out to be 14.85 meters per second. Inclination, if you find out, it is tan of theta 0 is opposite upon adjacent. Opposite is u0y, adjacent is u0x. That means theta 0 equal to tan inverse of u0y upon u0x. If you substitute here u0 and u0x, and if you calculate, theta 0 value comes out to be 52.69. Okay, this is 52.69 degree. That means what is asked in problem is u0 and theta 0. That means this is your answer, and this velocity what you are reading, this is your answer. Thank you.